Welcome and thank you for joining. In this lesson, we will explore limits at infinity and one-sided limits. Now remember that limits at infinity describe the trend in the y values or the estimated y values of a function as x approaches infinity. And by limits at infinity, we mean one of the following limits. So either the limit as x approaches positive infinity of f of x, and the limit of f of x as x approaches negative infinity. So whenever we evaluate a function at infinity, then we will have to operate with infinity. And remember that infinity is not really a number, so it's an undefined number. It's just a term or a word we use to describe an indescribable number. So when we operate with infinity, then we have to be a little bit careful because we'll be able to estimate most of the time and not just evaluate. So with infinity being an undefined number, we'll very often encounter situations when we'll be able not to evaluate a function at infinity. So in order to understand how to operate and how to find limits at infinity, then I invite you to go over some operations with infinity, which I think are important to understand, perceive, and imagine. So if you want to, and I'm going to stop the screen in here, so stop the video and try to answer these questions on your own. These are kind of logical answers, so you don't need a calculator for those. And I am going to go over and explain to the best I can, but they're quite doable and you can kind of figure them out on your own for sure. So we're going to start off with the first operation. So can we divide a constant number by infinity? So a constant number means it can be either a positive or a negative number. So I took different examples here. So if you have a positive number divided by infinity, I want you to imagine you have $1 and you are sharing it with the rest of the world. So practically everyone would get nothing. So $0, but technically or mathematically speaking, everyone should get something because you did share something. So we call this a zero, but because everyone will get something, it's going to be a little bit more than zero. So a positive number divided by negative infinity, here we have the division of a positive with a negative, which again will give or will have the size of 0. But because we have a positive and a negative, it's going to be a negative 0.00000 something. And because 0 is a neutral number, we call this 0 minus. A negative number divided by positive infinity will still be 0 minus. Remember, negative over positive. And a negative number divided by negative infinity, two negatives will make a positive, so that would be a 0 plus. So the next question we're wondering about is, can we divide infinity by a constant number? So here we took infinity and negative infinity and tried to divide by positive and negative numbers. So let's see. So if we have a very large never-ending number divided by a positive fixed constant number, then that large number will still stay positive infinity. So it will still stay very large. So a negative infinity divided by a positive number, negative infinity. Infinity divided by a negative, so we have a positive with a negative, so that's a negative infinity. And infinity negative with a negative will make a positive, so that's positive infinity. So yes, we can divide infinity by a constant. So the next question is, can infinity divide itself? So in other words, can positive infinity divide itself, or negative infinity divide itself, or negative and positive infinity divide each other? So remember that because infinity is an undefined number, it means that we have infinity over infinity, so we don't know which one is larger than the other. So it is very hard to compare two quantities that do not have a size. So this is where we say that infinity divided by infinity doesn't exist or is undefined. And the same thing will apply to when they have opposite signs or when they're both negative. So whenever we have infinity over negative infinity, so either one of these three cases, we are going to say that the limit will be undefined if we end up with these, right? Now, can we multiply with infinity. So a positive number with infinity, that would be still infinity. A positive number with negative infinity, a very large negative. A negative number with positive infinity, that would be a negative infinity. And two negatives will make a positive infinity, so still very large. So yes, we can multiply a number with infinity. Now, if you were to multiply infinities together, then we're going to say yes, two infinities together will create a very immeasurable quantity, still positive when the signs are the same. So two negative signs will make a negative when multiplied, and infinities multiplying each other will create a big infinity there, and two negatives will give a positive infinity. So multiplication of infinity by a number or by itself is cool. So now let's move on to our next question. Can we add or subtract infinity? Well, let's talk about numbers first. Infinity plus a number, still infinity, still a very large quantity. Any number, take away infinity, that's still infinity, but negative. Now, however, if we try to add or subtract infinities, the stories will change. We know that if we have infinity, we add more infinity to it, that can be infinity, so we can add these two. You have negative infinity, you subtract more infinity, that would be negative infinity, so even smaller, right? Infinitely smaller. And however, though, if we have infinity minus infinity, that is something we cannot define. So we're going to say that's undefined or doesn't exist because we don't know how much is in here that we're subtracting from here. So we cannot give a value to this difference. So just to keep in mind for the rest of the practice questions, infinity cannot divide itself, and two infinities cannot subtract. So let's take a look at examples now. As our first example, we're looking at this particular polynomial function, degree 5. We're trying to find the limit of this function or the value of this function as x approaches negative infinity. So as always, I will try the direct substitution. So I will go x equals negative infinity. That will give me 1 over 3 negative infinity to the power of 5 minus 2 negative infinity to the power of 3 plus 8. Now let's take a look at what happens here. So 1 over 3 is sitting here still. So if you have a negative large number to the power of 5, it will give a negative number still because the power is odd, and very large obviously, so that's negative infinity. And then we have minus 2, negative infinity to the power of an odd number, it's still negative infinity, and then plus 8. Keep simplifying. So a constant positive times a negative infinity, that's negative infinity. Now, negative 2 times negative infinity, that will give positive infinity plus 8. And obviously, if you add or subtract a number from positive infinity, that's still the same. So this is like negative plus positive infinity. And we said that we cannot define the size of this quantity because we don't know how much we're taking away from the other because they're both undefined. So we're going to say that this is an indeterminate form limit. We cannot define the size of this function at negative infinity. So how do we approach then evaluating or estimating the value of this function at negative infinity? So in this case, what we try to do is step number 1. So we're going to write the limit as x approaches negative infinity. Now step number 1 will be factor out the highest power variable, just the variable. Even if you see that there is a common coefficient, do not take that out. We're not interested in that because the trouble here comes from the presence of the variables in these terms, which makes impossible to add and subtract infinity. So we are trying to factor the highest degree variable. And once we do this, which in our case would be t to the power of 5, then we'll have to figure out what is left in the expression once t to the power 5 is out. So 1 over 3 will be left from the first term, right? Remember that that must reproduce whatever we had. And now it can be a little bit tricky at first figuring out what's left from here because we're getting out a power greater than this number here. But remember that whenever we are actually factoring something, let's say 2x minus 6, when you take 2 out, that is x, easy to remember and easy to do intuitively. But when we take a factor out, basically we figure out the other term by simply dividing this term by the factor you take out, right? So 6 over 2 is 3. That's how we know that what we're going to get here. So it's the same process that we're going to use in factoring out t to the power 5. So what we do practically is we take 2t to the power 3 divided by t to the power of 5, which is a factor now, and that will give 2 over t squared, right? Because power 3, power 5 will leave this one with the power of 2 here. So that means that we have minus and then 2 over t to the power of 2. And if you want to double check, t to the 5 times 2 over t squared, that is the same as what we had here. And then the same thing for number 8 now must be divided by t to the 5 so that we have, t to the 5 times 8t to the 5 equals 8. So it will become a lot easier with practice, obviously. So now that we have the limit or the function inside the limit in factored form, what we are going to do is substitute x by negative infinity. Sub in negative infinity. Well, it can be positive infinity, but in this case we have negative. So that means that we have negative infinity to the power of 5. Then in brackets we have the 1 over 3 minus 2 over negative infinity squared, and then plus 8 negative infinity to the power of 5. So negative infinity to the power of 5 is negative infinity to an odd power, so it will stay negative. Inside the brackets, we have 1 over 3 minus 2. Now, negative infinity squared will be positive infinity. And now we have 8 negative infinity, power 5 negative infinity. These look kind of cool together. So, same shape. And next, we have negative infinity. So we'll estimate now 1 over 3 minus, now 2 divided by infinity will be like 0 plus. 8 divided by negative infinity, that would be another 0. So this time 0 minus. So 0 plus or 0 minus, it is kind of the same idea in here. And we are going to say that this will equal practically 0. So remember, this is a simple estimation, so we're not evaluating exactly, right? It's a limit. That's what limit is about. And we're multiplying it basically by 1 over 3, which is negative infinity. So we'll say that the limit as x approaches negative infinity of this particular function is negative infinity. And when you think about it, we kind of know what the limit should have been and what the limit is, because we have graphed plenty of such functions. So this is a 5th degree polynomial function, so odd degree, and the leading coefficient is positive, so it will behave like the simplest odd degree function, so the line with a positive slope, which means that as x approaches negative infinity, the values of y will approach negative infinity. So the shape of this function will be probably a little bit more elaborate than the line, a straight line, but the end behavior is the same. So as x approaches negative infinity, the y values will also approach negative infinity all the way down here. Now try the next one on your own. I'm going to try to do this a little bit faster with not a lot of explanations, but just let's complete the steps So step number last here will be estimate the limit. And voila, 3 steps to evaluate this particular limits. So this particular limit I meant. So here we go. We're going to move on to the next example. So again, same idea, limit as x approaches infinity. So we'll have x to the power 4, the highest power. Then we have negative 2 minus 1 over x squared. Remember that x squared is divided by x4. When you take x to the 4 out, like every term here will get divided by x to the 4 to produce whatever we need to have in brackets, right? So that's why we get just negative 2 here, minus 1 over x squared here. And the last term would be 8 over x cubed, so minus 8 over x to the power of 3. So substitute x by infinity, so infinity power 4. Then we have minus 2 minus 1 over infinity squared minus 8 over infinity cubed. And we know that we're going to have practically a 0 for these two terms because we have a constant divided by infinity, which will make this infinity to the 4 infinity times negative 2. Infinity times negative 2 is negative infinity, and that would be the value of the limit. And when you think about it, this is a 4th degree polynomial function with a negative leading coefficient, so the behavior of this function will be that of a parabola that opens down, which means that when x approaches positive infinity, so the right end of the graph will be heading towards negative infinity. So this is how we find limits at infinity in polynomial functions. And in the next video, I will go over limits at infinity in rational functions where things get a little bit more interesting. Okay, thank you for learning with me and bye for now.